Hey everyone, thank you for being here. Good afternoon. So, this is my first time at Hackfest, and I'm super excited to be here. And also, I got my soldering badge,
Yep,
which
we
I'm
got our
proud of.
badges.
So, I'm gonna show this off. So, let's get started. It's mechanics of Malware's Darkside. How we came into this topic is we had a capstone project, which was to develop attack pattern matching rules, which is detection signature based on network logs. So we had to do extensive research on network traffic analysis and also malware behavior and malware analysis. Um, so a little bit about me. My name is Yagnesh Prabhakaran. I'm currently a wireless networking student at George Brown College. I recently graduated from the Network and System Security Analysis program. And my current interests include malware analysis and reverse engineering. That's why I'm here today. And also OSINT, which is open source intelligence. I'm a big supporter of Trace Labs, which are also, they're doing a missing person CTF. So OSINT is like really a big platform, and I'm like really interested in it, and also interested in threat hunting, and pretty much I'll leave the stage to my colleague Laura.
Hi, everyone. My name is Laura Harris. I am also a graduate from the same program as Yagnesh. I am currently working as a security analyst at a financial institution. No relation whatsoever to what I'm talking today, so don't quote me on anything. Current interests, malware analysis, that's why we're here. I come from a defensive background and I'm slowly moving over to the offensive side just because it's more cool, interesting, and challenges me every day. Other interests include digital forensics, as well as I might be moving a little bit into potentially doing a wearable right now. So that's also an interest. So just a little disclaimer, we are not experts at reversing malware. This is something that we decided to do as a side project, and we've only been learning it and doing it for about 2 months. And hopefully we'd like to do more in the future and be experts in the future, but this is more of just showing you what we learned and a basic malware analysis and simple reversing techniques that we've done so far. Oh, yeah. So we're also looking for potential mentors. I've heard that Montreal is a big reversing community. So please talk to us after. We'll definitely like to chat. So just a quick outline as to what we're going to be talking about. Intro to malware, reasons for analyzing, creating a safe environment, basic static, basic dynamic, and then after we collect all the information, how do we write our detection signatures for our malware sample? So what is malware? I think we all know it's just a piece of code that carries out some malicious action, whether that is to steal your data, to spy on you, or to gain any unauthorized access. So to give an example, I think we all know what TeamViewer is. It's a remote desktop software, and pretty much it's a legitimate software that has legitimate business use cases. However, if it's used maliciously, then it's categorized as a rat instead. So what is malware analysis? This is just the process of understanding what is the origin of the malware, what is its functionality, and what is the impact on your system. So why do we analyze malware? We do this for a number of different things: to determine the purpose, what is the damage it's carrying out on your system, and as well, we can do things like classify the malware if the sample is a new malware in the wild. And again, once we collect all of this information, we can create things like snort rules and YARA rules for your particular malware sample. So before we get started, we want to create a safe environment. And this is specific to the environment that we created. So we decided to use virtualization to make things easy. We could spin things up and spin things down according to what the malware was doing. So in our case, we're using two virtual machines, one that has a Windows image and another that has a Linux image. We're also disabling any shared folders, and we're changing our network interface to be host only, as well as unchecking automatically connecting our USB device. I think we all know, please don't be stupid. Don't run your malware on your host machine. So to talk about VM number 1, this is our Linux machine, and it's going to be running something called Remnix. So Remnix, similar to Kali, is a Linux distro that pretty much has all of these preset reversing dynamic and static analysis tools that you can use. So up on the screen is just a general setup as to what you can do. But for our particular Linux machine, we want to change our IP address to static. And I'll explain why we're doing that later. And we're going to be running a really cool tool called FakeNet in the background. For those of you who don't know what FakeNet is, this is a really cool networking tool that pretty much intercepts and redirects any network traffic while also simulating legitimate services such as a DNS server and things like an HTTP listener, HTTPS listener, TCP, and a UDP listener. So for our VM number 2, and this is going to be where we're going to detonate our malware. And this is going to be running something called Flare VM. So similar to Remnux, this is the Windows version and Windows distro that has all of these predefined tools that we're going to utilize. So again, just the setup as to how we can do it. So once you run the PowerShell script, everything's going to be set up for you. And we want to change our DNS IP and our default gateway to point to our Remnux or our Linux machine. So to kind of explain how we're doing it, on the right is the Flare VM. We're going to be running our malware there. So any traffic generated by that malware is going to be sent directly over to our Remnix machine. And this is pretty much going to handle all of our traffic. And if we want to respond to the malware, such as sending back any other files it needs, we can also craft that and send it back. On our Remnix machine in the background, we're also going to be running Wireshark to capture any network traffic that we can later analyze for further investigation. So before we get into diving into the deep analysis, we have to talk about the structure of our PE file type because we are looking at Windows malware. So what is a portable executable format? This is just a standard file format for things like Windows executables, Windows DLLs, core dumps, and font files. So the PE is made up of 2 parts. The top part being the header, which contains the technical details of your file. And then the bottom part is our sections, which contains the meat of the file that you want to investigate. So we're going to start with the top down. So the top is our DOS header. So this basically tells us that this is a valid binary file. The DOS header starts with the E_magic field, otherwise known as the magic number. So if you can see above, the value is translated to that hex value. And when we move it over into ASCII, it changes to MZ. For those of you who don't know, Mark Szabo is the creator of the PE file type and the design around it. Just a quick thing to note, there has been cases where this field has been changed, so it may or may not be a reliable source. Just a thing to note. And here, just a couple images where it shows you first field MZ and then the hex value at the bottom. So to continue, and again, we are still in the header section, is the PE header. And this just contains general characteristics of your file, such as size and location. Our optional header just contains even more further information about our file, such as our entry point location, our initial stack size, and then our OS version. Our data directory is just a pointer to things like our import, exports, and our resource directories. And that's it for our top part, our header. So now moving on to our sections, which is our meat, our content of our file. And in the sections table, we have things like code, import, export, and any additional files that the malware will be using. The code section is our executable code. Our import section is the link between the executable and any DLL libraries. And then the data will be anything like any global or local variables. I'm gonna drink some water because I am super thirsty. Sorry, guys. Okay, so within the sections, there are even more sections. And sorry to dry you guys with all this dry information, but it's good to know. So the predefined sections, there's usually 8 to 9. And depending on the malware's needs, there may be more sections that need to be created, or maybe not all of them will be used. So as an expert, you kind of want to go through all of these sections to make sure that nothing is being missed out. So just to give a brief overview, the .txt is our executable code, .data, variables, iData, import, eData, export, resources, icons, thumbnail, strings, anything that the malware will use. So to graphically show all that information, we're using a tool called CFF Explorer. So this is a portable executable editor that kind of lays out pretty nicely the hierarchy of your PE file type. In this particular slide, we're showing the import directory of our sample called pack.exe, and it shows you any DLLs it's calling and any functions that those DLLs are calling as well, as you can see on the bottom right. Same thing for the screenshot. This is the resource directory. And on the right, you can see any kind of resources it's using. In this case, it's using icons, menus, dialogues, string tables. So moving on to the types of analysis. So there's two types of analysis. There's static and dynamic, but we're going to start from static first. So what is static analysis? This is pretty much just examining a piece of malware without actually launching it. So also called dissecting dead code, because it technically is dead, hence the zombie. Couple benefits to doing static analysis is that it allows the expert to realize if this piece of malware or this file per se is malicious, because you can open it up and look at things like the strings it's calling, not the strings that are within the code, the functions that it's calling, and you can very quickly identify, is it malicious or is it okay? So to start with static analysis, unless you have some form of non-disclosure agreement or you really don't want your sample to be out in public, a good thing to do is to check it against antivirus. In this case, we just have a screenshot of VirusTotal because it's the easiest, and it pretty much just lets you know who in the community already identified this malware and what is the general functionality. So you don't have to spend as much time during your in-depth analysis when you have an overview of what it's doing already. So to move on, I'm going to hand it over to Yagnesh because I'm tired of talking for a little bit.
Okay. Thank you, Laura. So let's move on to cryptors and packers. We had some basic understanding of P file and what is happening. So starting with packers, they're also called runtime packers. What they do is they compress the file and also transform it. The main purpose is to make the file size smaller, and also like if you want to analyze, it's going to be a little difficult. Cryptors, on the other hand, also function as a packer, but they add another layer of defense. Like they'll add encryption, they'll change the icon type. It might be a executable, but it'll have an icon of a Word document, or it might have a icon of a Photoshop document. So it is going to help the antivirus to be like to evade from the antivirus detection. Tools to identify if it's packed or crypted. We are using something called exe info PE. It's a very good tool and it's very easy. You just have to open the executable on the exe info, or you can drag and drop to it. As you can see, it shows if it's packed. If it's packed with UPX, it shows what command you have to do to unpack. It says UPX minus TT compress. And also on the right hand, you can see it says don't unpack. So I was doing trying to decompile a .NET malware, and I used DE4 dot, and I couldn't do it. Like 10 minutes, I was stuck with it. Then I was like, okay, why not try this? And it clearly says do not unpack with DE4 dot. So that's pretty good, like to cancel out any unwanted steps. The next tool would be PEID. This has up to 460 different signatures of packers and cryptors. It also functions the same way. It's going to show if it's packed or not, and shows the entry point, which we'll talk about later. If you're someone who likes to do with command line, and also if it's UPX, if you know it's packed with UPX, you can just run the command line UPX minus T and output to the unpacked file. One of the key identifier to know if it's packed or not would be to looking at the sizes of the sections, like we discussed about the sections. So when you see the virtual size and the raw size, it's different. So virtual size is for section 1, which is UPX. It says 4,000 bytes, but the raw size is 0. It means that the code is executed during runtime on the memory. Let's look at the next thing, strings, which are like the sequence of characters found in the code. They can be ASCII and Unicode. Why do we need to find strings, and what can we find through strings? It may contain references to IPs, URLs like domains, C2 servers, and also any other attack commands or shell commands. Tools to identify strings, we are using like three types. And the first one to be used, the command line utility strings, which is Windows inbuilt. And the other two are part of the Flare VM. And it's pretty good. Like the second one, you can use the right click file for a GUI interface. The third one, Floss, is by the FireEye team. It'll de-obfuscate any obfuscation present in the malware. Like it does the most of the job. As you see in the screenshot, we are running through the string utility command, and it's for the sample, like simple malware. And you can see like it lists out all the strings found in it. And when you zoom it, you can see like the interesting function call it does. It tries to open the internet. It tries to connect to this website. It tries to call the process. So you have an idea, okay, this is what it is trying to do. That's the reason we want to analyze strings. If you don't like command line, you can use the right click file and open the strings, and it is going to show you all the strings, and you have the option of changing the size to detect if it's greater than 4 characters or more. And you can also search through the strings. Once it finished this analysis, you can search through the strings to look for any interesting, and you can also export the strings. Okay, so far we looked at like basic static analysis. Why shouldn't we just stop here? Like if you want to do a time of incident, you can just do a little bit of static analysis, get the key indicators and put it, okay, this is what's happening. But as a malware researcher, you want to do more. And for example, if a malware is encrypted, the code is encrypted, you cannot do your analysis without understanding the type of encryption. And also the strings used in the code does not mean they are called during runtime. Malware writers nowadays, they just input irrelevant garbage code and multiple loops just to confuse the analyst. So it's better to move on. Dynamic analysis is the understanding of the behavioral characteristics of a malware. And also you should note that the malware have functions embedded in them, which will prevent dynamic analysis. We'll look into it later. Before we do any kind of dynamic analysis, we need to utilize a feature called snapshot. Snapshot is nothing but it's going to save your memory, your hard disk, and your configuration to your local hard drive. And once you finish your malware like dynamic analysis where you detonate the malware, and you can after that you can revert back to the snapshot, a clean state. You don't have to like reinstall your Windows and then do it from beginning. Also, you can update the packages in your Flare VM. You can install new tools that came out like Ghidra or any other latest tools that's out. You can install it and you can take a new snapshot. Okay, let's move on to persistent.
Let's take a break for some shots. Never had this before, guys. It's good. Okay.
Let's show some demo.
Oh yeah, let's do a demo real quick. I think we're good on time. Time? Anybody? No? Okay, all good.
So we are trying to do the CFF Explorer.
So we're going to be opening up a packed malware in CFF Explorer. Because it is packed, we are not going to be able to see that much information. So you want to use a tool like PEID or exe info, and you want to drop your malware in there and make sure it's not packed. And if it is, you want to go and unpack it and then put it in your CFF Explorer.
You can also see the import directories, what are the DLL it's calling, and the functions it's calling from the DLL. It gives you a basic idea what DLLs are imported during the process. These are the resources directly. This is a pretty good tool to get started with. It gives at least a basic understanding of the PE file used. So let's run the exe info to detect the type of package. It's just simple. Just you can drag and drop the pack. If you want, you can or click file open. It's going to show you, okay, UPX unpack with UPX. If it's not packed, so this was a Linux malware. So you can see it says not Windows exe. Probably try ELF pack. Most of the samples that you pull from malware sharing website, it might be with a different extension. It might even be without an extension. So you guys have to figure out what kind of malware unless it's not specified. This is not packed, so it says not packed. Just go ahead with debugger. Then we are running the strings where you just right click. So it's all Flare VM. So we are having this multiple options in our context menu. So you just run right click on strings. You can find the list of strings. And this is pretty interesting because the kernel one, it's not kernel, it's kern 132. It's mimicking the L and the 1. So you'll have an idea, okay, this is what's happening. And the same package, once if it's packed, you can see, oh, okay, it's packed with UPX. And there's not much strings because it's packed. Once we unpack it, we can find all the other strings that are being used. So this is some fun stuff. This is a variant of Mirai botnet, and this has some basic strings, which you can see the IP and the get request for the command and different types of agents it's scanning for. You have like, you don't have to go disassemble. You don't have to like debug to know all this. And you can also see the Yakuza, like, okay, oh, this is what is happening. It looks for scans for IP ranges and sends out messages if it's connected. So as port 23, yeah. Okay. Let's continue with the persistent.
Cool. So continuing on with dynamic analysis, we're going to figure out how to identify persistence. So persistent/persistent techniques is pretty much a way how the malware can stick around even after you have closed the file, you've restarted your system, and you have changed your credentials. So a couple places, and they're not the only places that persistence can be established, is if the malware installs itself into things like Windows logon registries, image file execution options, scheduled tasks, startup servers, accessibility programs, and so on. So in our case, we're using Process Monitor to identify persistence. So this is a tool that's used to monitor pretty much all of the system events, such as file creation, process creation, registry key value changes, and so on. However, because Procmon is a little bit high in RAM intensive, we decided to use a Python script called Noravent. So this pretty much just kills all of the extra noise and then gives you the suspicious indicators that are associated with your malware that you're detonating on the system. So it's a really neat tool. It runs Procmon in the background, and then once it's done, it closes that and then outputs some information into a CSV and into a text file. So this is the output of Procmon, and as you can see, process created. It shows you that pack.exe, sample1.exe, and unpack.exe, all of which were malware that were detonated, created some form of process. So again, removed all the noise and gave you kind of that key path to look at. Another tool that we decided to use for dynamic analysis is Wireshark. I'm pretty sure we all know what that is. And in our case, we are using it to capture any network traffic generated by the malware that we launched. Again, just a recap of the architecture that we did. We're detonating the malware on the Windows machine. Remnix is collecting and redirecting and intercepting all of our traffic. And on our Remnix machine, we are also running Wireshark in the background so we can get a valuable PCAP in the end. So a couple different indicators that we can get out of Wireshark is we can find, if you're enterprise level, you can find the host name of the potential infected IP, infected machine, host names, domain names, IP addresses of the C2 servers, and other additional downloaded files that the malware may have gotten from the C2 server. So in the next screenshot, we're able to see the domain that the malware was trying to connect to. In this case, it was called corpcougar.com. Other one is just the host name of the infected machine. And Wireshark has a really cool tool where you can extract all objects from your PCAP that you got. And in this case, the malware tried to download another executable called purchaseorder.exe. So we were able to extract that and actually see what this other executable had inside of it. So another tool that we like to use during dynamic analysis is a disassembler. And this pretty much just changes machine level language over into assembly level language. So a really cool feature of a disassembler is that all of these malware these days can detect if you're in a VM or if you're in a debugger. So once you try and launch it in the debugger, you may find yourself not getting anything because the malware will stop or it won't do what it's supposed to do. So you can open it up in a disassembler and go line by line and understand its functionality. So I'm going to give it back to Yagnesh to continue on disassembler.
Thank you, Laura. So we are using IDA Pro as our disassembler. IDA stands for Interactive Disassembler, and IDA is a powerful tool, like really powerful tool. And IDA and machine like assembly language is a big area. It's another day for another time. So today we want to look into like open your executable in IDA, and it's going to pop up showing the different function it calls. What we want to look is for anything interesting that's happening. So for example, you can see, okay, this is calling advanced API 32.dll, and what kind of function is calling from load library. And the next is get proc address. As we saw in a packed executable, load library get proc address means packed executable trying to unpack during memory runtime. And also look for interesting, like look for XOR functions. XOR means like the code is encrypted and you'll have an idea, okay, it's encrypted. Let's find out where the encryption is happening or what kind of RC4 encryption or any other type of encryption is happening. The next tool would be to use a debugger. Debugger is a computer program which you can execute in a controlled environment, and also you can halt the function at specific interval or specific breakpoint by setting like, okay, when this function, this code hits this function, just stop there. I need to modify something there. That's handy when you're changing the, like in the previous slide we saw, it says if debugger is present. So you go into the function and you modify the value saying, okay, debugger is not present, so you can jump onto the core of the code. For debugger, we can get started with Ollie debugger, and it's a pretty good tool to get started. You open the executable, you run through the code, and you can modify in live. Like the pretty good feature is you can modify the code real in runtime, and you can patch it. And this is very good to avoid the anti-VM and anti-debugging functions. So why we are doing all this? Why we want to do the malware analysis? Like, why don't we just leave it to the experts? So we want to create rules, the detection rules. And Yara is something common. It's an open source tool where all the malware researchers are using it to classify based on the specific characteristics of the malware. And also Yara will detect for the signatures, and it will alert a trigger to your IDS or IPS. So far, these are the artifacts that we saw. So some interesting strings and also the MD5 hash value and the fuzzy SSD hash value from VirusTotal. A simple Yara rule to detect that virus would be to have their hash value and the SSD, and the strings, it has like 5 strings, which we found, okay, it might be malicious, and the condition would be 4 out of 5 strings. So what happens when runtime, when Yara detects, oh, this executable has like 4 strings out of the 5 strings in my rule, bam, it sends a trigger. You can also, it's just not with strings, you can include your IPs, you can include the URLs that you found, you can include the domain names and whatnot. Next tool would be Snort. Snort is also an open source intrusion detection system. Snort functions in the network level, like where it detects the communication between a malware or 2 systems, and it triggers the alert. A simple syntax, Snort has a very simple syntax. It's rule, protocol, source IP, source port, destination IP, destination port, and message options. Let's look at the example of the Petya ransomware. Like when after they analyzed the ransomware, and they like, okay, let's do a Snort rule. This is one of the Snort rule it had. It says alert SMB. Alert is type of the alert, if it's going to alert or log or like what it's going to do. And SMB is the protocol where what it used to communicate, and any source, any port. It can come from any source, any port. Destination IP is your home IP that you're protecting, and it can be any port. The message title will display like Petya ransomware perfc.dat component. That will be your alert title. And when you look at the content, it says SMB, and the second one says a bunch of hex characters. So what this hex characters transform to ASCII is perfc.dat. So technically what happens is when there's a communication happening on network level, so it's going to detect for any packet that has this content. So if it has this content in the hex value, it's going to say, oh, I found this communication, and it's going to generate a detection. It's going to say to your IDS. So if anyone is interested to get started, like how we were like a couple of months back, so trying to figure out like, how do I begin with this? It's so vague, like it's so new. Just follow, like we followed a reverse engineering workshop called,
Let them take it.
yeah, can take a picture.
Yeah. Give them a couple minutes.
So the reverse engineering workshop by Malware Unicorn, it's pretty cool. Like it covers the basics, and if you want to learn more into reverse engineering, you can get started with that. And also there's tons of malware traffic analyzing exercise, which is involving Wireshark, and it's by malwaretrafficanalyst.net. It's by Brad Duncan. He's a famous like researcher. And 2 books we would recommend is Practical Malware Analysis and Learning Malware Analysis. These are like really good. They cover the basics. And as when I started, I had no idea of assembly language. It was like really new and like,
Gibberish.
wow.
Yeah.
So these books cover the basic, and like, okay, it'll make sense once they have a separate chapter to cover assembly language. So for the tools used, these are not the list of exhaustive tools. These are like some of the easiest tools that you can get started with. There's plenty of other tools. Like as we said in the Flare VM, you have tons of tools for reverse engineering, debugging, reverse engineering, different types of packed malwares like .NET, Java, all kinds of tools. And the minimum requirements would be to run on a Windows 7 Service Pack 1. We know that Windows 7 is going to be like support is going to be stopped, but it's fine. So what next? We looked into some small tiny malware, some simple malware, but what do you want to do next? There are other things you can do. So nowadays there are obfuscated malware, where obfuscation is a technique to make the process of analyzing very difficult. When you look at the screenshot, you see it's I'm not sure if you can really see it, but it looks like a lot of gibberish, like a lot of, for a normal person, it looks like, okay, I don't know what's happening. There's no function calls or anything. But if you go deeper, if you pull apart a single variable, it calls for a particular index of each character. Like there's a huge list of string, but it is calling for the 75th character, 44th character. And at the end, it arrives to chmod. Chmod, as you know, is a Linux command. And normal basic detection doesn't work. Like you can't identify. That's when you have to go do it manually and see, okay, this is what is happening. And also, Android malware is like really trending, and they mostly target with adwares, and also like nowadays it's like you have ransomware. I'm pretty much sure it is for the old mobiles which no longer being supported. For example, we had the cam scanner which had an advertised dropper, and they took out the Play Store. And also a couple of weeks, I think couple of days back, they found 42 adware apps with 8 million downloads. We might be having one of them in our phone. So to get started with Android malware analysis would be, I think yesterday Christina spoke about it. If you guys were at her talk, she would have covered about the different types of adware evasion techniques that are being used. So first thing would be to analyze Android application fundamentals. And then there's another tool called Andro Lab, which is similar to the FlareVM, also has all the reversing tools for Android, and a simulator like reverse engineering lab. If you are someone who don't like Windows, I'm not Android, you also have like Linux. People say there's no malware for Linux. It's not true. Linux are being like targeted with IoT, like mostly they are targeting IoT devices with botnets, and also the Linux servers facing the web. So latest would be Mirai, which has been happening for so many years. Even the source code is out, and what people are doing is just modifying a little variable and creating a variant of it. And there's a recent one, sophisticated hidden vast malware, and this is like the common right now. It's like really trending. And this malware like deletes any other malware that's on the Linux, so it can occupy all the resources and it can run. So for the resources to get started, same as like portable executable for Windows, we have to know the basics of ELF and what is happening. So ELF is also like similar. It has the structure, and you have to understand what's happening. And if you want to pull malware samples for Linux, there's a GitHub repository called the Zoo, and you can pull all kinds of Linux malwares and Windows malware. Also, you can run the malware in a sandbox. There's a Linux sandbox called Lisa. It does pretty much all the automated, and it's really helpful. So when we were doing our slides, we also were like researching and like looking up everything. Something that we found was not we found, we came across is the smallest PE file, where it can download a file from the internet and execute it. It's very amazing because the file size is only 133 bytes, including the header and everything. This is a code, and you can see it's just it utilizes the UNC import and calls the DAV mini recorder and downloads the file from this IP. That's all it does. And the file might be anything. The downloaded file might have anything on it. The next one would be YARGen, which is a Yara generator. It's automatic Yara rule generator. We spoke about writing Yara rules, but this one is like it already writes the Yara rule like for yourself. Like give a database of malware, like 10 malwares, as you see in the screenshot. It's too small, but what it does is it looks for 10 executables, and then looks in the strings and compare with the good strings, and then says, okay, these are the strings, excludes the good strings and identify the bad strings, and creates a rule by itself. And this is by GitHubification of InfoSec by John Lambert. He's a very famous researcher. What he says is like how we should contribute, how we should download, how we can be as a community, we can develop this and be one step ahead. So for the analysis, using common tools, using Jupyter notebooks, using virus total and all those stuff, detection product would be using like the log analysis, Splunk, Sigma, all those rules. And detection definition would be something similar to what we saw, Yara Snort, and technique database would be Mitre attack. And all these, once you combine, once you correlate, once you like get help, like you don't have to, a lot of now what's happening is like vendors are trying to protect their latest antivirus and not provide it to everyone. So that's like a bad move, but yeah, So what we can do is collaborate with, as a community, we can collaborate our resources, share, and be up to date with the antivirus detection. Threat group is once you have a pattern, once you know, okay, this is what is being used, okay, this might be APT 41, APT 23, and you will know if you're a target, if you're being targeted by them, or it's a common attack.
Also, if anybody has some obscure malware repository sitting down somewhere that you'd like to share, please also talk to us after.
So that would be it from us. Some references we use. Also, the last part of demo, just quickly.
We good on time? Yeah, we're good.
So I'm using VirusTotal. This happened like a couple of days when I analyzed a sample that was being analyzed the first time. So it took a while. This I did the second time just for when I wanted to record. So I did it like 21 minutes ago. And it shows like, okay, it's been detected by all this existing antivirus. And you can see Avast AVG is not detected yet. So if this virus runs on any system that has Avast, Kaspersky, or AVG, it's not going to detect. And you can have other details like extensive details that says MD5 hash types, when this file was submitted. If it's an old malware, it's going to show this malware was submitted on this day. And any other like section information, what are the DLLs that are used. So this virus tool is like pretty easy. It gives out everything that we wanted to do, like on the static analysis. And also it executes the malware and shows some behavioral indicators where it shows files open, what are the files that were open when this malware was executed, and the files returned, temporary files, registry keys modified, if it's trying for persistence. And VirusTotal is not free, unfortunately, so you need to buy a paid version. Once you have a paid version, when you go into the community tab, you can see what are any other researchers that have uploaded, any other vendor that has uploaded, and it gives a pretty extensive graph view, which shows like the malware, which IPs it is communicating. That IP might be hosting many other domains, subdomains. So this is when I'm trying to execute a malware. I'm running the Noriban as we spoke earlier, the Python script. Once it invokes the procmon, so procmon is also running in the background. Now I'm switching to my Linux Remnex machine. I'm running the FakeNet module. So FakeNet is already pre-installed in Remnex. You don't have to install it again. So all this happening in our analyzing environment, like we change the IP to static and it's not connected to the internet. So Wireshark, so right now the FakeNet module is trying to change the drivers and simulate the services. So once it finishes, you can see the traffic being generated in Wireshark. So 10.0.03 will be my Windows 7 machine, which is trying to communicate with the Remnex. I'm filtering with my source IP. So I go back to my Windows 7 and I'm trying to execute this is a simple malware. It's not trying to do harm anything. It's just trying to open the browser and connect to a domain. So just open and it's going to the particular URL. You can see the URL host name. Okay, you know what's happening. And when you filter with DNS protocol, okay, let's execute the next one. So this is more like fileless malware. So once it's executed, it's going to delete itself. Sorry, it's gone. So you have no idea what happened. And you can see what domain it was connecting to. It's going to connect to the russk6.eic. This was the payload that was sent. So you have a basic idea. Okay, this is trying to send. Some might be stealers where they're trying to get your credential and then post it. Famous is right now is Emotet, which steals your credential. This is another malware which is trying to communicate. you can filter the Wireshark. If you're familiar with Wireshark, it has thousands of filters, and you can, once you filter with HTTP, we can export what the objects like from the HTTP. Just go to file. So you go to file and export objects and HTTP. So what happens is any executables that's being downloaded over HTTP, this PCAP is going to have that file. So one good example for that is a fileless malware, where it downloads, it runs, and it's deleted from everywhere. So you have no clue what executed. So when you want to do your analysis, you can generate the executable from your PCAP file. I quit Noribin, then it's going to generate me a CSV file. It's pretty good because I ran a ransomware and it was still able to generate me a CSV file without being encrypted. That would be, yeah. So that would be my CSV file list of all the process that was happening and any files created. That's it from us.
Cool.
Thank you guys for
Thank you
being here.
guys.